Hello class, welcome to the first online lecture on the skeleton. We'll be doing the axial skeleton, so skull and vertebrae. That's the plan. Here we go. So, looking at this picture, just to remind you, of course, we're looking at humans, and we'll see we have, as adults, about 26 vertebrae, vertebral bones, and we have 12 pairs of ribs. If you look at this snake here, it's going to have like 300 or 400 vertebrae and hundreds of ribs, right? So, pretty cool. So let's begin. We're going to go through the bones. This is something we're going to do in lab. So you have the chapter to read. You can listen to me. You have the Cloud lab. You can do this one. You'll do ahead of time, and then in lab we'll go over, be able to touch the skulls and see the skeletons, and we'll help you really solidify it. But whatever it takes to help you guys memorize all of these bones of the body, we're going to do it. So the first bone is a weird one here. Looking at axial skeleton, so skull, vertebrae, ribs. It includes this hyoid bone. Like you can feel your Adam's apple, and about fingers width above it, you'll feel this, especially if you feel back here, you'll feel this U-shaped bone. Don't press too hard. Matter of fact, forensically, when they find a skeleton, if the hyoid bone is broken, it's really good evidence of strangulation or some kind of neck trauma because it's a delicate bone. It's a U-shaped bone and can easily break. And in us, it doesn't articulate with any other bones. It's just in the skeleton, it's floating there with a piece of wire. And in us, it has ligaments and muscles that attach to it. Yeah, and so you feel your Adam's apple, which is your larynx, which is made of hyaline cartilage. And above it's this hyoid bone, this U-shaped bone for tongue muscles. Yeah, very cool, interesting. All right, so when we look at the skull, we have a cranium up here, which is going to hold the brain. It's like a big football helmet, right? And then we have facial bones, our lower jaw, these bones here that hold our teeth. So they make up the bones of our skull. You can put it into cranium, this huge cavity that holds our huge brains, and then talk about our facial bones up front. So let's begin. We'll just go through them. The frontal bone is right in front, your forehead, easy to remember. It actually develops as two bones, and then they fuse in the middle. Sometimes you'll even see a little bit of a suture there in an adult's skull, but rarely. It's a big, solid bone. It's going to make up the roof of our orbits up in here, and you have sinuses in here, some hollow areas. And I remember a doctor hitting me with a little hammer here because I had stuffy headaches, things like that. See, oh, okay. Kind of feel if they're hollow or not. So you have sinuses that drain out into your nasal cavity inside of them. And then usually up above, there's either a hole or a notch where you have this supraorbital nerve artery veins will come up onto your forehead like that. So if you get the skull there, yeah, it's either a little notch or a little hole. Supraorbital means above your orbit. And your orbits are your eye sockets. And looking over here, you can see in yellow. So that frontal bone, not only does it make your forehead, but also makes up the floor of your cranial vault, where the frontal lobes of your brain will sit right here. And here's the sinuses. We'll talk about those next. Technically, they're the paranasal sinuses, which means they're like parallel, like paraprofessional, paralegal. They're next to your nasal cavity. So they're paranasal sinuses. And sinuses are just big spaces. And you see these in the bones of your skull here. And we'll see the biggest ones are your maxillary sinuses. And then you have a big sphenoid one and some big frontal ones. And then the ethmoid bone is a little bone that has some little air sacs in it. But all of these sinuses drain into your nasal cavity. So if you have a sinus infection, can travel from your nasal cavity back and forth. If you have sinus pressure, they're filled with fluid. So it's that same nasal epithelium. Remember what it is? What kind of epithelium? pseudostratified columnar with cilia that continues to these little holes into these sinuses or hollow spaces in our skull. And so you can see how infections can go back and forth, and they can get filled up with snot, right, and fluid. And what do? Why do we have sinuses? Well, they lighten your skull. If you didn't have sinus, if it was solid bone, your skull would be a lot heavier. They also act kind of as resonating chambers, like in a violin or a guitar, to amplify your voice. So you sound different if your sinuses are stuffy. So 4 bones in the skull. Frontal, we just did the frontal bones, the only bone. We're going to see big maxillary sinuses, your biggest ones. And then a sphenoid and ethmoid sinuses. And these maxillary ones are actually, they don't drain that easily when we're sitting upright or standing. The other ones drain, gravity can help drain them into the nasal cavity, but this is going almost upward. And so people sometimes with stuffy maxillary sinuses will toss and turn when they sleep, because on one side will drain. If they turn their head the other way, the other side will drain. And here you can see the extent of these things. These things are huge. It's maxillary sinuses. If you're in a cadaver, chip away the bone, you can stick your whole finger in there, your whole thumb in there, and move it around. And on top, you're just thin bone separates your maxillary sinus from your orbit. And then another thin bone separates it from your teeth. You can feel the ridges of your teeth. So you can have a tooth infection that affects your sinus infection, or sinus infection can cause your teeth to hurt because it's just really just small separation here in the orbit. So big and hollow here in your maxillary bone, which is your upper teeth. And here you can see some frontal sinuses too. Yeah, here you can see a couple issues here where you see all the fluid in the bottom. So you have fluid in your maxillary sinuses here. You're feeling stuffy. And then looking at the 2 nasal cavities. So we have a right and left nasal cavity. We obviously have right and left nostrils. And those cavities are completely separate. We're going to talk about the 2 bones that form it and the cartilage that forms the septum or the wall between your 2 nasal cavities. But right and left are separate. You can see that bony wall here, right? And then you can have a deviated septum. Remember, it's to the side. It's hard to breathe out of one nose. And then I'm looking at these little scroll-like bones that you have in there. Yeah. So on either side, you have these 3 conchae bones. Conchae means snail, like rounded. They're delicate bones. And they're covered with that warm, moist epithelium, so that when you breathe in through your nose, the air is filtered and warmed and moistened. So that's what that surface area is for. Yeah. And we'll see the top 2 are part of the ethmoid bone, and these will be inferior nasal conchae, have their own bone. And then there's a wall between called the septum. Septum is a wall between the 2 right and left nasal cavities. And we'll see, this is going to be the ethmoid bone. It's going to be the vomer bone. So I'm throwing things at you. So just a little preview. So your nasal cavity is right and left, completely separated by the septum or wall. And then coming into it, these scroll-like bones, which you can see here in the CT scan. And you can see that this person's, depends on the orientation, but on this side is going to be all stuffy. See that? And antihistamines would probably bring it down. All right, so giving a lot at you now. Sinuses cause a lot of problems. People with sinus infections and sinus headaches, but these spaces in there, because they're continuous in the nasal cavity, infections can go both ways. And but they do lighten your head, and yeah, I wonder if there's a way. I'm just thinking out loud how we could fill those up. Well, then it's going to change things, isn't it? All right, well, just trying to think outside the box how we can help people with all these sinus problems. All right, so look at our skull. And you might have noticed I like to put humans into context with our closest relatives, other mammals, and because it doesn't make sense just to look at us as this unique being here. We're just part of a whole family of primates and mammals, right? And so we have this huge football helmet of a head. So we have a huge brain. And so our cranial cavity is just expanded. We have this forehead that holds the frontal lobes, just huge. We have a pretty small, relatively small face and small jaws compared to our closest relatives, looking at chimpanzees and other apes. You can almost see a little line here, and you can see it in a real skull better than the plastic skulls, but it's all for big, huge chewing muscles that'll come down and attach onto your lower jaw. And it's not that impressive, actually. Look at this, our chewing muscles. Sure, we can bite like hell, right? We can give a strong bite, but nothing compared to getting bit by a gorilla, or a dog or a cat. But indeed, when we see this thin little, bar here that comes here, underneath is chewing muscles, and chewing muscles have been the outside too. That will raise that lower jaw. And I'll show you, I can show you a whole bunch of skulls. You look at a wolf or a dog or something like that, and they have a big crest up here. And then so their chewing muscles have a lot more surface attachment. Our chewing muscles here, this temporalis, is just on a flat skull. And then one more thing with this is that when you look at a human skull, when I look at a human skull and I put us in context, what I see is really a juvenile chimpanzee or ape skull or something like that. And what happens in the great apes, the other great apes, is that they continue evolving the skull so that their jaw is big and these big ridges and crests here like that. And just to put this in your mind here is that a powerful force in evolution is when you have mutations in the genes for development. And what most certainly happened in humans is that we retard development. We stop it so that we end up with a juvenile skull, which has a larger brain case and a smaller face. Yeah, and so if you look at, I'll show you a picture. Here's an infant chimpanzee. It looks damn human, has all these things. And if you let this chimpanzee continue to grow, the jaw grows out and things start changing. So we think humans have big brains. We have a long period where our parents take care of us, and we're hairless. So a lot of changes, differences between us and our closest relatives. But the skull, certainly when you look at it, seems to have been stopped in its development, which doesn't make it bad. Like they're not more developed or less. It's just we end up with a skull that's more juvenile looking when you look at our closest relatives. Look at this big male gorilla. Yeah. And so this crest is what I'm talking about. So this is all for muscle attachment. So they got a nice strong bite. We just have this smooth, a little bit of a ridge, you know what I mean? But you look at a fisher cat here in Maine or a big wolf or dog, anything like that. They've got this big crest on the top, and it's for muscles. They have thick chewing muscles, and we're very wimpy when compared to the bite of a lot of other mammals. All right. So back to looking at our cranium. We got the frontal bone, and then back here is our parietal bones. And so we have a right and left parietal bone. And these sutures, when you look at these skull bones, how they're attached, they're not attached like this. They're attached like this. They're sewn together. And that gives it so much more strength, doesn't it? If they were just together, you could easily, if your head gets hit, you can imagine them moving or separating. But if you have sutures, like when you suture someone up, you have this complex interdigitation or connection here, much, much stronger. And that's what we see in our skull bones. And you need to know the name of some of these. And it's pretty easy because you know this. You know this. This is your sagittal suture, like a sagittal section, right? And your coronal suture, like that coronal section. So a couple. And then back here, this one's kind of L-shaped back here, it'd be the lambdoidal. And then just to finish it up, you're going to have a couple squamous sutures on the side. All right. So the parietal bones make up, large flat bones in your skull. And finally, so you have frontal, parietals. The back of your head is the occipital bone. This is the thickest of these cranial bones, real thick in the back of your head. You can still land on it and crack it, but it's pretty strong back there. And it's called the lambdoidal suture. Back here, yeah. And then here we'll see what's called the squamous suture. Here's the coronal suture. You can't see it, but on top will be the sagittal suture. So these are major sutures that separate these big cranial bones. The occipital bone back here, of course, is going to have a big hole in it where your brain leaves, and then we call it the spinal cord, called the foramen magnum, which means the big hole. A foramen is a window or a hole. Occipital condyles. Condyles will be these areas that are smooth for connection between two bones. There'll be some cartilage there. The occipital condyles, we have two of them. They're going to articulate with the first vertebrae in your neck. Yeah, it allows us to do this movement. Yeah. And some people have various ridges, protuberances in the back you can see, especially if you're shaved head back there. All right, a complex bone, we move to the sides, is this temporal bone. You can think of these are your temples, right? So your temporal bone, if you look at it isolated here, it's got many parts to it. You can see, oh man, it's got a lot going on. And it is a pretty complex area. It's fairly thin here. So, you know, if you play softball or baseball and you're hitting, you get protection there because you don't want to get hit right there with a fast pitch, right? But looking here, you can see the squamous portion is like squamous cells, a big flattened portion. And then you'll see this external auditory or acoustic meatus. Meatus is a big cave that goes in there. It's your ear hole, going to your eardrum. And then your zygomatic process of the temporal bone is going to come out to make these zygomatic arches where you have chewing muscles going underneath them. And then I want you all to feel just underneath your ear, there's a big bump right here. And that is your mastoid process. Mastoid. It's kind of like, to Greeks, kind of breast-like, like a mastectomy mast. So it's kind of rounded. And you can't feel this, but your styloid process is close by, but just it's a little deep in your neck. And it's very pointy. Your styloid process is very pointy. And what does that mean to you guys when you talk about a stylus? Probably you're thinking some kind of phone or personal device that has a little pen, the stylus, right? And in the old days, in a record player, the needle is called a stylus. So it means pointy. It's a pointy little thing. If that helps you remember, styloid process, oh, it's pointy. We're going to talk about a couple of them in the skeleton. Yeah, what else? You'll see here this mandibular fossa. A fossa is a depression, and that's where your mandible or lower jaw is going to articulate. So this joint's called the temporomandibular joint. It's going to be where your jaw articulates. Yeah. Cool. I'll show you some more pictures here. So yeah, we're still in the temporal bone. If you look at it here, it's the green in the skull. So you can see you have temporal lobes of your brain that sit on it on either side. Yeah. And this portion in particular is really solid. You don't have to know it's called the petrous portion, like petrified. And in there, it's going to hold your ears, your middle and your inner ear. So in there's going to be your little ear bones, little malleus incus stapes, right? And for balance and for hearing, it's going to be in there, really hidden in this temporal bone. I remember when I taught gross anatomy, I offered extra credit if anyone could dissect and find those little bones. And I did have a student that did it, but they're tiny. It takes patience with the bone saw to cut through that temporal bone to get in there. But it's going to be holding your little ear bones in there, well protected. Yeah, it's another view here, looking at the temporal bone. You guys see it on the side? You see that auditory meatus for the ear hole, right? You see the mastoid process. You're going to have a big neck muscle, sternocleidomastoid, attaches onto it. And then that styloid process is really pointy. It's often broken off in the real skulls. With the plastic skulls, you'll see it, obviously, these little points. And people say, what's that for? Why do you have a little pointy thing in there? You can't even feel it. It's for muscle attachment. You're going to have styloglossus, stylohyoid, stylopharyngeus. You don't have to know those muscles for this class, but you got muscles that come off of it that are going to attach onto your tongue and your hyoid bone. All right. And the joint, our mammal skull, especially our human skull, it's akinetic. There's not a lot of joints in it. The only joint really, besides your ear bones that can move, is your jaw, your temporomandibular joint. So the temporal bone has that little fossa in it for the socket, and then your mandible is what we call your lower jaw. And so it's going to articulate right there. And this joint is really complex and it's subject to injury and wear. All right. If you look here, look at all the vectors, all the ways that it can move. It's a hinge joint, technically, like, but also it's a gliding joint. So not only can you hinge, open your jaw, you can move it side to side, you can protrude or retract. So you can see, when you think about it, you can really move that jaw around when you're chewing your cud or whatever, chewing gum or something like that. And people that have TMJ, this is a temporomandibular joint, it's an issue. My mom had that issue. If you grind your teeth at night, sometimes it will grind this little pad of cartilage that's protecting it. And you imagine you grind it, and then you have a lot of pain. And so you have to wear a mouth guard to sleep with so you don't grind your teeth. But not only the teeth can be ground down, but this joint can cause a lot of pain. So maybe some of you have TMJ or know someone with TMJ. So that joint, you can see complex movements and a lot of pressure when you're biting down, especially if you grind your teeth. And so you can have injury to that joint. All right, I think I'll finish up the skull here, and then I'll take a break and do the vertebrae in the next one. Sphenoid bone is a weird one. Sphenoid bone is kind of, here it is taken out of the body. Kind of looks to me like a spaceship going through. Kind of like a butterfly to some people. It has a couple of wings that come out like that, but it's kind of in the middle. And so here you can see it's in yellow in the skull. See that? So you can see it on the sides of your skull. It makes up a lot of the back of your orbit. Let's see here. Yeah, so looking at here at the skull, you see the yellow. So yeah, it definitely makes the base of that cranial vault. Your brain's going to sit right on there. And then looking at the rotating skull, look at the green. So you can see it shows up a little bit on the side, makes a lot of the back of the eye socket, and then it'll make in the base of the cranium too. So it's kind of stuck in there. Obviously very important, and you can kind of view it from different angles, or it kind of peeks out. And it has a pretty nice sinus in there that opens up in the nasal cavity. And then we'll talk about the sella turcica. Yeah. So looking at it, one thing that's going to be pretty obvious is this region here is kind of cool. It's got this little depression. And sella turcica means Turkish saddle, roughly. And it's kind of saddle maybe you put on an elephant or a camel kind of thing. It has a front and a back, it's more substantial than we put on a horse. And in there sits your pituitary gland, which we'll get to beginning of next semester. Pituitary gland has all kinds of hormones that do all kinds of things. So it sits deep in there. So deep, if you want to do surgery on it, you can't even go from above. There's too much brain. You got to go through the nose to get up to it. So well hidden in this little saddle is this little pea-sized pituitary gland. All right, and then kind of rounding things out, right in front of that sphenoid is this ethmoid bone. It's got sinuses in it, really tiny little sinuses that open into the nasal cavity. Looking at it, it's weird pulled out of the skull, but you got these two big lateral masses. You can see they have hollows in them, right? But then when I'm looking in the middle, I see this perpendicular plate going north and south. So that's going to make up a lot of your nasal septum, in the nasal cavity, the wall that comes down. Okay. And then on the other hand, going up into where your brain is, you have this crista galli, which is going to be this little crest that comes up, which I'll show you in the next slide. What else we got? The ethmoid bone makes up the superior middle nasal conchae that will come in. Not really shown very well here. Yep, a little bit into your orbits. When you look in there, you got sphenoid, a little bit of ethmoid. Here we go. Here's another view of it here. They don't separate the colors out very well, but where I circled is going to be where the ethmoid bone is, where you see it from above. And the biggest wall goes downward, and it makes up most of this wall of between the two nasal cavities. So this perpendicular plate of the ethmoid bone. All right, now you're saying to yourself, what about that part that comes up, that crista galli? See that thing right there? I'll show you. Yeah, right here. And it's a rooster's comb kind of comes up, and it's a ridge that comes up. And I'll tell you what it is just real quickly. We'll get to this the next section. Inside your brain has two hemispheres, and there's this big kind of wall or ligament that attaches to it. So that's what it's for, in case you're curious. That's what it's for, yeah. And then you look here, you see these little holes? Look at these little holes. They're called olfactory foramina. A foramen is a window or hole, remember? So these are little olfactory nerves go through for smell. So this is where your brain would be, looking at this picture, and you're gonna have these two bulbs that sit there that attach to the rest of the brain. And that's where the nerves for your smell are gonna go through. And these little olfactory foramina, when you look at all of them together, call that your Cribiform Plate. Let's see if we show that. Yeah, we're looking at it right here. So Cribiform Plate is going to be this plate. It has all, it looks like a sieve. It has all these holes in it. So this whole thing is a Cribiform Plate, and the little holes are your olfactory holes or foramina. All right. All right, let's go looking at the face here. A real important bone that's kind of like the keystone right here, makes your upper teeth and it goes up into your eye sockets. This is your maxilla. So these upper teeth are your maxillary teeth. And so the maxilla also was two separate bones. It's one of the last bones to fuse together in the adult human. And so sometimes they won't fuse and you'll get a cleft palate, right? A cleft lip, cleft palate, because they haven't fused quite right. But normally it's a single solid bone, and it's because it's fused, and it's going to make up really the middle of your face here. The maxilla is all of this. Yeah. We talk about the part that holds the upper teeth being the alveolar process. Alveoli are little sockets, and so it's your dental arch. It's where the upper teeth are going to be attached to your maxillary bone. Huge sinuses in here. Talked about the biggest sinuses, your maxillary sinuses that drain into your nasal cavity. And they come up into your orbit. Your orbit has all kinds of bones that make it. You can see we're getting a sphenoid here, a little ethmoid we talked about. See the green is the maxilla. It comes up to, and then a couple more. And then you can't see it in this picture. I'll show you the next, is that this maxilla makes your hard palate. So looking here, you can see, oh, this is the part that holds my upper teeth. And then here's the palatine process of the maxilla. It makes the palate, the roof of your mouth, the bony part, yeah. And this part comes up into my eye socket, and I have a huge maxillary sinus. Yeah, that's what this maxillary bone is doing right here. And so the roof of your mouth, if you feel it, is your hard palate, is the bone. You have a soft palate behind it with a little uvula that hangs down. That's made out of cartilage. But the bony part, and the anterior part, is made mostly about 2/3 from the maxilla. So the maxilla holds the upper teeth, and it goes up and it makes the roof of your mouth. And then if you go back a little further, this orange is going to be a bone called the palatine bone. Makes sense, it's your palate, right? But most of your hard palate is made up of the maxilla bone. And here's the palatine bone. Yeah, so it's going to make up that posterior part of your hard palate, and then it comes up on the sides. So it's kind of like two L-shaped bones. Your cheekbones right here are called the zygomatic bones. Can be broken, you know, you get a hit right there. So zygomatic bones are going to make part of your orbit and then your cheek. And there's going to be a little process that comes back to meet the temporal bone to make this little bar where you have chewing muscles go underneath it. See here? Here would be your chewing muscles. They go underneath this little bar. Actually, they'll attach right here, like that. Yeah, so the green there is your zygomatic bone. Parts of your orbit, temporal process. Temporal process goes back and meets the zygomatic process to make what's called the zygomatic arch, which is this bar of bone. Yeah, but some of you have more prominent cheekbones than others, since your zygomatic bone we're talking about. Looking at here, see the blue here, you're going to have a lacrimal bone. And lacrimal means tears. So it's going to be a little hole in that where the tears can move from your eye into your nasal cavity. Yep, so two little lacrimal bones. And then right here, that makes up the bridge of your nose, are the nasal bones. So your nose is mostly cartilage, but here's the bone. So you have two little slender nasal bones. Lacrimal bones, think about tears, they're in here. All right, so back to this perpendicular plate, this nasal septum between your two nasal cavities. The superior part is your ethmoid. The one underneath is called the vomer. I believe it's German for plow. Kind of has a plow-like look to it, see that? But it's that pink down there. And so if I ask you, what two bones make up the nasal septum? You say the ethmoid and the vomer. I say, what two bones make up your hard palate? You say maxilla and palatine. I'll ask you those. And then the inferior nasal conchae are little scroll-like bones that are their own bones. There's a middle and a superior, a part of the ethmoid. Here's vomer. I like using different languages. Sometimes you can see this. Limb perpendiculare. Oh, I'm not gonna butcher that. But here you can see, here's your ethmoid and your vomer. And then here will be cartilage filling it out, but it makes that septum or wall between the two nasal cavities. Beautiful. And you guys see your hard palate, your bony palate? It's giving me up of your maxilla and palatine. I think we're left with the jaw, the lower jaw. We call it the mandible. So your mandibular teeth are your lower teeth. And in us, it's actually one of the characteristics of mammals. You all think make milk, have hair, and also we have a single jawbone. If I was to grab a alligator skull, it's made out of 4 or 5 bones. Fish, half a dozen bones make up the lower jaw. We have a single lower jawbone. We think it gives it a lot of strength, stability. Our teeth meet or occlude just right? So our molars, each little cusp meets together. Because mammals, we need to really get as many calories out of food as possible. So we really crush our food and chew it. An alligator or fish, they don't chew. They bite to kill their prey, but then they just swallow it. Swallow it. Matter of fact, a snake, the two bones aren't even connected. There's a ligament, so they can the jaw can open wide. And fish, they can put their upper jaw up and the lower jaw down to make this big gape, right? But we have an akinetic skull. It's very solid, and our teeth meet just perfectly so that we can really chew our food, because mammals are expensive. We need our calories. We need to break down our food, increase the surface area so we can rapidly digest it. All right, there's my big picture about our lower jaw. Down to the nitty gritty, we take a look at it. It's obviously shaped like a horseshoe. And then ramus is a branch. It's the part that comes up. It's a little more slender, comes up. And then there's a coronoid process for insertion of this chewing temporalis muscle. And then the mandibular condyle is smooth area for bones to come together, occipital condyles, is you can see the shape of it. It's roughly oval shape like that. And that's what makes that TMJ joint. It's a hinge, but also can go side to side and rock forward and backwards as well. So mandibular condyle of the mandible is going to articulate with the mandibular fossa of the temporal bone. I might be coming at you fast and furious here, but take your time. We'll go through these bones. We'll look at them in lab. Just giving it to you here. When I look at the mandible, the alveolar process is going to hold the lower teeth. And some of you are definitely dental hygiene, interested in that kind of thing, interested in the teeth. The upper teeth, the nerves come down to each tooth. The lower teeth, you guys know you can deaden the whole half by getting that needle in there, right? And it deadens everything. And what else does it deaden? Your lip and your chin right here, right? Well, I'm going to explain why. You have a whole mandibular foramen. How easy is that to remember? Mandibular foramen, the hole in the mandible. And then you have a nerve artery vein that comes in. It's going to go. It serves all the lower teeth. And it comes out this you have 2 little holes here called the mental foramen. I think like the thinker. Rodin's sculptures, they're like this. So on your chin, you have 2 mental foramen. And so if you can just deaden that nerve, it's going to deaden all the lower teeth. And then it's also going to come out. The nerve comes out this hole and goes onto your lower lip right here. All right, what do you think? Got your mandible? Just have one, it's solid. Yeah. All right, that's pretty cool. All right, I think it's time to take a break. I was going to just go through the vertebrae also, but I think I will split it up to give you guys and myself a little bit of break. So there you go. We've gone kind of quickly through the bones of the cranial, facial area, and we did the hyoid in the neck as well. All right, hope you enjoyed.